Good afternoon everybody. I am Vikas from Chiptronics and today we are starting our first class of online laptop chip level repairing. In this course we will be discussing about all from simple steps to all advanced steps of repairing any dead laptop motherboard in whatever condition be it be. We will be using all equipments and we will also be using all the simple procedures to repair a laptop. There has been very much confusion in this market about how to repair a laptops. Several institutes, several people have started teaching how to repair a laptop motherboards. Here we'll unearth the myths of laptop repairing. We'll discuss all the secrets, how we used to repair the laptop at our own service center. We'll tell you about those steps, those theory. Let me briefly introduce about myself. I am Vikas from Chiptronics and I did my BTech in electrical engineering from IIT BHU Varanasi in 2008, and from 2006 onwards I have got my interest in this hardware repairing. So we'll start with laptop repairing. To properly repair a laptop you must have to understand first its schematic. Any schematic of any electronic device explains its various connections in the circuit, its various signals. So in this, for repairing any laptop motherboard you must have an access to its schematic diagram. Properly repairing a laptop motherboard, there are, I think 90% things are same in all the laptop motherboard, but in some 10% things it varies. So you must, if you have an access to a schematic diagram, you would be in a good condition to repair a laptop motherboard. The problem comes from where you will get a schematic diagram. You can always contact Chiptronics to have an access to any kind of schematic diagram. In this session we will discuss about the focus on one laptop motherboard DV2000, but the things which I am explaining is common to all the laptop motherboard. The name of the signals would be same but its position would be different. So you have to remember the name of the signal. You must not focus on position. Let's start with the schematic diagram of DV2000. First page. In any schematic diagram of laptop motherboard, the first page explains its block diagram. This is block diagram. This is CPU, this is GNCH, this is DDR RAM slots, this is IC8 that we call it as Southbridge also, this is IO chip, KBC IO chip. So these are all block diagrams. In the first page of any schematic diagram you will see the block diagrams. Inside the blocks you are seeing some page numbers 4, 5, 6, 7, 8. So this 4, 5, 4, 5, it means in this schematic everything about this processor would be in page number 4 and 5. So if you want to refer about any signals or any connection of a processor, you have to see the page number 4 and 5. Here in this block you are seeing all the voltage regulators. What are voltage regulators? Voltage regulators are the power supply, specific power to the IC. Each IC requires some kind of a specific supply. For an IC to operate, it requires three things: power supply, reset and signal. These are the universal regulators. Universal regulators means these are the main source of power supply onto your laptop motherboard. Like 1D05S0, from wherever 1D05S0 is written, it is coming from this 8743, max 8743. Then you have 5 volt 3.3 volt IC, regulator IC. This is 5 volt S5 3V S5. So this is 5 volt 3.3 volt regulator IC. We will discuss about this power section also in later session. In this class we are discussing about this CPU supply. So we will move on to page number 4 and 5. Please go to page number 4. Now when you are seeing this block diagram, you will be bogged down to see so many signals. but we must not concentrate on all signals. We have to only know signals which are important for repairing, which are important in this section. So please note down the important signals which I am explaining. Like, what is this? This is one section of your CPU. U49A. When you see in your laptop motherboard, you will see U49 written over your CPU socket. This is U49A. This is U49B. That means your U49 section, that is your CPU processor, is divided into various sections. This is U49A. Here you are seeing control. This is H clock. So we will be discussing the important point. In this section, there is important point H CPU reset, which is coming from GMCH. This is the first signal that it has to come from GMCH. This is H reset. You can measure 1.05 volt. In thermal section, any CPU will have this section, thermal section. There will be one thermal diode. This is thermal anode. This is thermal cathode. This is proc hot. Proc hot means processor hot. Then this is thermal trip. Any processor needs sufficient heats to operate. Until and unless it gets sufficient heat, this processor won't start. So there is one, if this CPU gets sufficient heat, it will generate a signal called proc hot, CPU processor hot. You can measure this signal here. And there is thermal anode, thermal cathode. This signal is going to page number 20. Please refer to page number 20. Connected. Only things is connected, two things. SGN-D2 and SGN-D1. H thermal anode, H thermal cathode. If the CPU releases this signal, then this controller will release this signal, fan signal, to the fan controller. Here, this signal is coming to the fan controller. Then this CPU fan will operate. So a CPU fan will start moving. When this signal, when your processor doesn't get appropriate heat, then this signal won't come over here, and this regulator won't generate this fan signal, and so your CPU fan won't run. Let's go back to page number 4. So we have discussed this part. Now there is a CLK underscore CPU BCLK. This signal is coming from the clock generator. Page number 3. What is? Let's go back to our block diagram. Clock generator. This clock generator is issuing a signal CLK underscore CPU BCLK. When you insert any processor, when you insert any kind of processor, this processor will generate a signal to the clock, that is at what frequency it has to run. Because there are two kind of frequency, two kind of speed in a laptop motherboard or in any kind of device. There are two speed. One is the processor speed, the speed at which this processor calculates data. It has to be definitely higher than this FSB. In the first page of the block diagram we have to move. First page. See, here is written host bus. This is front side bus. This is front side bus. This is the speed 533,667 megahertz. This clock generator will tell to, this CPU will tell to clock generator that this is my FSB speed. One very conceptual question occurs, that why there are two speed, one processor speed and one FSB speed. Because your other chip like GMCH, ICH, these chips are slower. These chips work at slow speed. You cannot afford to run the entire chip at the same speed. because when data moves from your chip to the connectors, if they move at the same speed as CPU, then this data won't reach over there, because this data travel through various buses like PCI Express bus. This is host bus. So what are these buses? These are connections. These are physical connections on your laptop motherboard. If the data has to flow at such high speed, then they will radiate, they will act as an antenna. The two wires will act as an antenna. The data won't reach to the connectors. So we have devised a lower speed, that is called FSB speed. So this CPU will issue a signal to the clock generator telling that my front side speed is this. Then this clock generator will give a return signal to the CPU. Okay, this is your FSB. We'll go back to the page number 4. So this signal comes from the clock generator. You see page number 3. Go back to page number 3. In page number 3, see CLK, CPU, BCLK. This signal is coming from the clock generator. So the clock generator will issue a signal CLK, CPU, BCLK. Similarly, this signal is going to MCH, that is GMCH. This clock generator will issue a similar kind of signals to the all, to GMCH, to ICH, everything. Let's go back to page number 4. So for studying this schematic diagram, you have to similarly go front and back into your laptop schematic diagram to understand it properly, to understand the sequence. Here why we are discussing this theory, because we have to understand the sequence, in what sequence it's operating. Then we can diagnose a problem. There are two ways to solve any kind of problem. One is the iterative way. You go on removing MOSFET, capacitor, chip, and you can solve a problem. You can solve any kind of laptop motherboard, but it will take so much of time. But there is one second way. One is diagnostic approach. When you know all the kind of signals, you will be exactly able to diagnose any kind of problem, and you can solve the same problem in a lesser amount of time. That's why it requires certain kind of theory to understand. Now, slide. Yeah, one more signal is there in this part, FERR signal. FERR, H underscore FERR. This is the signal the CPU generates when it gets all these signals. When FERR is coming, it means your CPU is working perfectly fine. F underscore FERR. You can measure this signal. You can measure this signal at the socket. Okay. Next, this is U49A. We have discussed this part of U49. U49 is divided into many sections. U49A, U49B. In U49B, there are some important signals. This is CPU select. This goes to page number 3. CPU select 0, CPU select 1, CPU select 2. This signal goes to clock generator. That is, when you insert a processor, this processor will issue a signal to the clock generator. Here you see CPU underscore select. This signal will go to this clock generator, and this clock generator will generate a signal, that is here CLK, CPU, BCLK. This signal will goes to CPU. Here you are seeing the back and forth. You have to go back and forth to the page to understand the sequence. But we have to take this block diagram, our basic block diagram, into our mind. That is, first step, GMCH giving H reset signal. Second, CPU giving CPU B select signal to the clock. Clock giving return signal CLK underscore CPU BCLK. This is a signal name. This signal name will remain same in any kind of laptop motherboard. The pin number might change. So we have to remember this block diagram. We have to keep this block diagram into the mind and get access to schematic diagram and see where these numbers are there on that pin to understand this thing. Go back to page number 4. So here the important pin is CPU underscore select 0, CPU underscore select 1, CPU underscore select 2. Move to page number 5. There is one more signal, power good. This power good, this signal is coming from the ICH. This is very important signal. You have to measure this signal at the CPU socket. You can measure voltage at this signal. 1.05 voltage is there at H power good. You can measure this signal with multimeter. We will cover the practical aspects also in our next session. How to measure these signals, we will discuss about these things. So there are two important signals, CPU underscore select 0 and power good signal, H power good. In your block diagram you can see this signal. Here, ICH is generating H power good. This is the last step for this CPU section. Go back to page number 5. We have covered this page number 5. Yes, here. This is power supply of a processor. Any kind of Intel processor, they require three kind of supply. Three supply. One is VCC core. A common misconception among people is there that a processor requires only one supply, that is core voltage. We always talk about core voltage. Core voltage, that processor is getting core voltage or not. But for a processor to start, it must have three supply. VCC core, 1D05, 1D5, that is three supply. VCC core, 1.05 volt and 1.5 volt. It has to get all the three voltages to operate. We will discuss about how this CPU core supply is coming. This comes from voltage regulator. Through a number of steps, this voltage is generated. Here the important pin is VID pins. What are VID pins? VID pins are important for self-correction, self-adjustment of required voltage. If the processor doesn't get exact CPU core voltage upside, if this processor doesn't get exact voltage, if there is some differences between the exact voltage and the supplied voltage, then this CPU can self-correct that voltage through VID pins. Through VID pins, it will generate signals to auto-adjust the voltage, auto-adjust the CPU core voltage. We'll discuss about these VID pins in the data sheet of the processor. We'll look how a data sheet of processor look like, what is VID, what values when 101, like see here, H VID 0, 1, 2, 3, 4, 5, 6. This 6 bit, this will have different values. If all 0, if all 1, if 0, 1, 2, 3, what values it will generate? This values, this VID, it's going to page number 33. Go to page number 33. This will be the page of voltage regulators. VID, see, this is coming to the main voltage regulators, main CPU voltage regulator. This pin, this signal is coming over here. This is the main, this is core voltage. See here, DH1, LX1. We'll discuss this thing in voltage regulator section. How this voltage regulator works. This will auto adjust the voltage over here. Here, see, this voltage is the core voltage. Here, see, VCC underscore core underscore S0. This is your main CPU power supply. So that signal is coming over here. The VID pin signal is coming over here. So that this voltage regulator can auto adjust its output over here. If there is any difference in the voltage, when you insert a new processor, sometimes the processor will issue its exact voltage. So it will autocorrect by that VID pin. We'll discuss this thing in our power regulator section. Go back to page number 5. So we have discussed these pins, VID pins. Now we'll come back to our main block diagram. So we have covered this. GMCH issues a H reset signal to the CPU. CPU issues a signal CPU underscore B select. Then clock generator issues the signal CLK underscore CPU B CLK. Then CPU core voltage, CPU regulator. The CPU regulator supplies the core voltage. If the core voltage is different than the appropriate voltage required by this processor will issue required signal through VID pins. This VID pins signal will go to CPU regulator as we have seen. Then this CPU regulator will auto adjust its output of core voltage will go back over there. The CPU thermal diode, thermal anode, thermal cathode, it is connected to the fan. If the CPU is not getting appropriate heat after powering on, mind it, it's after powering on, it must get the required core voltage, because until and unless it gets the required core voltage, it won't get heated up. So this step is after this. It will get its core voltage, it will generate heat, and if there is not sufficient heat generated, it will issue a signal thermal trip, and the ICH will issue a thermal trip. But the last step is ICH issuing H power good. After issuing this H power good, your CPU will start working. Your CPU will start generating signals. Important signal. So this is the last step. This is the first step. Here, H reset. Then this is clock signal. CPU second step. CPU telling to clock that this is my FSB. The clock will generate. Clock generator will generate CLK underscore CPU BCLK signal to the processor. The CPU regulator is giving core voltage. Now when we'll discuss the power parts, voltage parts of the motherboard, we'll see how this CPU core voltage is generated. It's generated through a number of steps. This is ACPI, Advanced Configuration Power Interface. Why this is launched? So that your motherboard do not get burned at extreme case. The voltage is flowed in sequence. This we call ACPI, Advanced Configuration Power Interface, so as to save energy, not to power on everything at one time. So we'll see how this core voltage is generated. After it gets the core voltage, CPU will receive a signal to the fan controller. That is also called hardware monitor controller. There are two terms: fan controller, hardware monitor controller. So today in our section we have covered this thing. One very important thing we'll discuss about is difference between various kind of buses, because though this is not required in repairing, but we must understand the differences between various kind of buses. Somebody says this is PCI bus, somebody says this is PCI Express bus. So what are the differences between various kind of buses and how a bus operates? In earlier system we were having only PCI bus, and now it's a PCI Express bus. So what is the difference? We'll go back to our first page number 1. Here you see each chip has a separate bus, PCI bus. This is separate connection for this chip and this chip. There is no division between the data. The data is flowing separately. That is PCI Express. PCI Express is a point-to-point connection, and PCI is a bus where you can connect many chips and they distribute. In that case the data is in that case speed is distributed. At one time only one chip can work. In the PCI bus, at one time only two chips can communicate. While in PCI Express there is a dedicated connection. You see PCI 16, PCI Express 16. 16 means 16 bit. This is PCI Express 1, that is, it means 1 bit. So PCI Express 16 means 16 bit. And how we implement this 16 bit onto your motherboard? Each bit is equivalent to 4 physical wires onto your laptop motherboards. Why 4 wires? 2 for receiving and 2 for transmitting. So that at one point of time it can do both activities. Transmit as well as receive. So 2 wires for receiving and 2 wires for transmitting. So in 16 bit there will be 64 wires onto your laptop motherboard for connecting this. And again one question occurs, why 2 wires for transmitting and 2 wires for receiving? So we will see this thing. It's a bit theoretical, but we must understand this. We will go back to our materials. Here, see, I will share all these materials with our students once they join, and I have already given these materials to my students. What is the different kind of bus, how this bus is implemented, like you are seeing ISA, Mika, then PCI Express. Here we will be discussing about differences between this PCI and PCI Express, because there is slight misconfusion. Every time I hear that this is PCI bus, this is PCI Express bus. So there is I was telling that each bit is implemented through 4 wires onto your laptop motherboards. Yes. Each bit is implemented through 4 wires. It means when there is PCI Express 16, it means there would be 64 wires, because 16 bit, 1 bit implemented through 4 wires. 2 for receiving, 2 for transmitting. Now again I was telling you why 2 wires, because see here, one is the right signal, another is the inverted signal. Through one wire the right signal is flowing, and through the another wire the inverted signal is flowing, so that at that destination they can match these 2 signals. There would be 0 error. If there is no error, the value would be 0, so that it can match. In the 2 wires it can match that signal, so that no error occurs from the source to the sink. When there is a communication between the data, they have to devise certain ways in order to assure that the data flows properly. There is no error in the data. That's why for transmitting 2 wires, for receiving 2 wires. So 1 bit equivalent to 4 wires. 2 wires for transmitting, 2 wires for receiving. 16 bit means 64 wires. 1 bit means 4 wires. So PCI Express 1 means 4 wires, PCI Express 16 means 64 wires. Go back to our block diagram. So we have covered this entire block diagram. So while thinking about CPU section, we have to take care of all these important signals. All type of boards, maybe it be HP, Acer, Lenovo, Toshiba, all these signals are same. How to measure the signals, where to measure these signals, we'll do it in a practical class. We'll go and measure these signals with a digital multimeter on any kind of board. In our next session, we will cover the practical class of this theory. We will implement this theory in the practical class. So goodbye for this class, and in the next class we will start with the practical application, how to measure all these signals, and in the second class we will go with GMC. Such a step by step we will move all these things in a sequence, and then we will collect all this theory and we will repair a dead board, we will repair a board with no display problem, we will repair a board with SATA fault. All these problems we will discuss how to do in steps. We are technical people. Here we are finding ways to repair a laptop motherboard. We are not over here to create a laptop. For more information, you can always go to the data sheet. You can always read through the data sheet. And your feedbacks are very important. You can ask questions during the class. Alright, thank you.